Hey everyone, welcome to my Slidecode demonstration. Slidecode is a tool I wrote in Python and assembly for shellcode encryption. It places a header at the beginning of the shellcode and allows for normal shellcode to be encrypted with no nulls and then decrypted in memory and executed. So let's go ahead and start by looking at it. So far I've created a virtual Python environment which allows me to download and install Python without affecting my global settings. I have Slidecode downloaded and installed from GitHub. To install it, you'll need to do pip install -e and then the folder that you installed it in. In this case I installed it in Slidecode. Since I already had it installed, it uninstalled it and reinstalled it. Now to use Slidecode, we use the module syntax for Python. And we'll display the help menu first. So here's the Slidecode help menu. We have a few options enabled so far, or available so far. Our in file is the name of the shellcode we'd like to be encoded or encrypted. Out file is the output from this program. This will be the header plus the encoded shellcode plus the trailer. We can enable verbosity. Verbosity will print out individual XOR encryptions. This is mostly useful for debugging and if you want to see some of the error messages. Lastly, we have keys and trailer. The program comes with default keys. However, you can change them if you'd like to. You can see there are the defaults in hex. You do not need to use the 0x or /x headers for hexadecimal. The program will parse just those hexadecimal values and turn them into the appropriate binary representation. The trailer is appended to the end of the shellcode, and this is necessary to find out the size of the shellcode dynamically. Again, you don't need to pass in a /x or 0x to append to the trailer. By default, the trailer is hex AABB This is not normally executable. If you'd like to have an executable trailer, you can change it to something like 4 nops, like hex 90, 90, 90, 90, or something else. Keep in mind this will need to be unique, because if the code finds it before the end of the shellcode, it will assume that was the end, and things just may not work right. So keep in mind the trailer does need to be unique. Let's go ahead and encode our shellcode. We're going to start by looking at a basic nop sled. So we have 32 nops as our shellcode. You can go ahead and open that. You can see here in nops.bin we have hex 20 or 32 decimal nop instructions. So let's go ahead and run this. Our in file will be nops.bin. Our out file will be, we'll call it slidecode demo.bin. We'll turn verbosity on for this point, and we'll leave keys and trailers alone for now. So we can see that it ran and worked, writing encoded payload to file. Here you can see the individual XOR encodings if you wanted to debug if something went wrong. The other important messages that are worthwhile to see are these first few. First few bytes of the provided shellcode, we can see that it's hex 90s. This gives you a sanity check that you're reading in the right file. And then the first few bytes of the header, you can see here EB02, EB05, E8F9. Those are the first few bytes of the header, and those are actually part of the decoding instructions. So if you see those, you're good. Let's go ahead and open up the file we just created, again in our hex editor. At the beginning we can see the EB02, EB05, E8F9, like we expected to see in the header, and we can see our default trailer, A, B, B, C, C, D, D. And all the stuff in between is the rest of the header and the encoded NOP shellcode that we're using as part of the demo. So this all looks good, but how do we know that it works? So for this demonstration, I've created a small project in Visual Studio that uses a little bit of Windows internals to allocate space that's read-write executable, and puts the shellcode in there so we can trace its execution. First, we're going to copy all of this out, and we can do that using the O&O editor. Has a copy as C code option. So we'll copy it, we'll open up our small project, and we're going to paste it in here. Hex data needs to be changed to shellcode, but otherwise this will work. You can use any sort of shellcode loader that you want to test this. If you've taken software exploitation or advanced software exploitation at DSU, you'll recognize the beginning of this code. I'm not going to show it here. We're going to go ahead and build. Currently Slidecode only supports 32-bit assembly, Intel assembly, so we're going to build just for 32-bit. We have our build that was completed. During testing I had tried this, so it says 1 up to date rather than 1 succeeded, but we know it worked. Now we're going to use WinDebug to open it up and follow some execution. We're going into our Slidecode demo project, and we're going to open up the demo executable that we created. To get to the beginning of our shellcode, we're going to use Go or G, and we have to do it twice. The first one is to get through the loading process. The second one is to get to our breakpoint that's in the code before we start executing our shellcode. We can see here our shellcode loader running, and we've arrived at our own int3. So we're going to step through a couple instructions, and then we'll end up at our shellcode. Here we can see the beginning of our shellcode. We have our EB02, EB05, E8F9. That's the beginning of the header that we've seen before. This shellcode is a little bit of shellcode gymnastics to get the current location of our instruction pointer. We do this to make the rest of the shellcode easier, and some of the weirdness of it revolves around making it null-free. So let's go ahead and execute these instructions and keep going. So EAX now holds the beginning of our shellcode. We can see in the registers here. In this case, it's 138,000, more than 1,000, hex 138, 10,000, however you want to read that. Our first step is to find out the size of the shellcode. So this first loop is going to go ahead and walk the shellcode until it gets to our trailer, and the number of bytes for this shellcode will be stored in ECX. So let's do one iteration and then we'll skip ahead. So in ECX you can see we're at 1. We'll do it one more time. Now you can see we're at 2. We're going to skip ahead, and now you see ECX holds the value hex 20 or 32 decimal. That's the size of our shellcode. That's what we would expect. So we now have the length of the shellcode dynamically. We didn't need to include that anywhere in the shellcode. The next bit of this header is the decryption process. So it will go through and XOR, decode, or encode, depending on how you want to look at it, since it's the same operation, all of the bytes of our shellcode and return them to what they were. To see this, we're going to look at two different things in memory. We're going to look at ESI in this memory view, and EAX plus 88 in this one. We can see here that we're looking at the exact same values right now. And the ESI one will change with every rotation. We increment ESI to move to the next byte, but this EAX plus 88 will stay the same, and we'll see our hex 90 bytes show back up. Let's go ahead and walk through this a few rounds and show you, and then we'll jump ahead. we can begin to see some of the hex 90s show up in our EAX, and you'll notice ESI is slowly moving. You're seeing less and less, and you can see that address on the left-hand side incrementing. Once we get through all of these hex 90s, when ECX equals 0, as you can see the counter slowly going down, when ECX hits 0, we will take this jump equal branch that I just stopped on in the disassembly window, and that will take us directly to our shellcode and begin execution. Let's keep going, we're almost done. We're about to see the last few hex 90s appear in our second memory window. And we're now at that jump equals. We can see the branch equals 1, that BR equals 1. And when we take this jump, we start execution right at the beginning of our NOP sled. In this case, this would be the shellcode that had originally been encoded, and we'll begin execution. Once you get to the end of your shellcode, you will end up at the trailer. That's where I mentioned if you want an executable trailer, or if you don't care, then that's fine. But it will eventually attempt to execute that trailer if you don't account for that in your shellcode. So that's the demonstration of the Slidecode tool for shellcode encoding, XOR encryption, XOR encoding. I hope you enjoyed.